Hey guys, welcome to my channel. In this channel we will try to discuss a problem and explore all the possible solutions which will eventually help us to solve other problems and most importantly help us to think about all the possibilities of a problem. In this video we are going to look at LeetCode problem number 226. Let's say we are given a binary tree which is like this, starts with 4 to 7, right? We need to invert this binary tree. So we can start from the root, which is 4. Then we can swap the children. Then we can swap the children of 7, right? So which will be 9 and 6 after swapping. Then come to the 9, there is no children, and 6, there is no children. Go back to the root and go to the right. 2 has 2 children, right? 1 and 3. So what we can do, we can swap, which is 3 and 1, and come to the 3, there is no children. Come to the 1, there is no children. So this is the inverted binary tree of the given tree, right? Now what will be the algorithm for this? Okay, let's say invert tree. We are given a root. First of all, we can check if root is null, then return root, otherwise swap root dot left with root dot right. Then we have to do the same thing repeatedly for the child, which is invert tree for root dot left and invert tree for root dot right. Finally return root. So this is our algorithm, right? So we did the same thing over here. So we first of all visited here 4, and which is not null, then swap the children, which is 2 and 7, right? After that we are calling the recursive call again for, we are repeating the same process again for the left child, which is 7, right? Then 9, then go to the right child, which is 6, eventually 2, 3, 1, and everyone. So then finally return the root. What is the complexity for this algorithm? Let's say complexity wise we have to visit every node, right? So that means time complexity is big O n. N is the number of the nodes. A space complexity, we are creating a stack frame in every recursive call here, right? So at most in this tree we may have at most how many stack frame? So we can have 1 2 3, which is the height of the tree, right? So this is the height of the tree, or this way, right? This is the height of the tree. So space complexity is big O h. H is the height of the tree. But if the tree is something like linked list, right, there is no left, all the tree node has a right child, that becomes a linked list, right? In that case, a stack frame would be like big O n. So we have to create n stack frame here. Okay, so this is the worst case scenario. So this is the worst case scenario, and this is the average or best case scenario. So this is the approach 1 using recursive call. Now let's consider the iterative approach. So we are given the tree. Let's say this is 7. Okay, so in this iterative approach, I would like to use queue, so that we have a queue over here. First of all, I want to put the root in the queue, which is 4, right? Then I want to pop the 4 from the queue. So, and this is our 4. Then I want to swap the children for 4, which is 7 and 2. Then I want to keep the children into the queue. So I already popped out the 7. Now we have 4. Now we have 7 and 2, right? Then from the queue again pop the 2, then swap the children, which is 3 and 1, and put 3 over here and 1 here, right? Then again pop 1, then swap the children. So 1 doesn't have any child. Then go back again queue, pop 3 doesn't have any child, okay? And then pop 7 has child, which is 9 and 6. Put the 9 and 6 in the queue. Then pop 6, there is no child. Pop 9, there is no child, and queue is empty. That means this is now an inverted tree of the given tree, right? But in this approach we did not use recursive process. Instead we used queue. So what would be the algorithm for this? Algorithm Invert tree, we are given root node, right? Again we can check the condition. If root is null, then return root, okay? Otherwise we can have a queue. In the queue we can first of all we can add the root here, then we can loop through the queue while it's not empty, right? So first of all, we can take the we can pull the item from the queue. So let's say current is queue dot pull. Then we can swap current left with right. Okay, so this is a swapping here. So this is what we did here, right? So after pulling the 4 from the queue, then we did the swap the child. Then we can, if current dot left not null, then we can add current dot left, right? Similarly, if right is not null, we can add to the queue. So this will repeat until queue is not empty. Then finally return root. So this is our algorithm, right? Now what is the complexity here? For time complexity, again we have to visit each and every node. So which is big O n is the number of nodes, and a space complexity is at this time we do not have any stack frame here, so there is one improvement here. We do not need to worry about a stack overflow, but we are maintaining a queue, right? We are maintaining a queue here. So that queue, what is the queue size at most? So in this scenario, the queue size could be like, we are first of all we added 4, then 7 and 2, right? So queue size could be like the label nodes. For example, this is in this time, this it maintains this level, which is 7. So similarly for this one, it could maintain this guy, right? So that is label nodes. So what is the number of label nodes in a certain level? That would be the queue size. So in a tree, in a particular level, the node is like n by 2, which is n by 2. So this is like yeah. So this is the space complexity, which is, let's do big O n. So what is the improvement here? The improvement is we do not need to worry about a stack overflow. That is the main advantage using queue instead of recursion for this problem. Now let's solve this problem. First of all, I would like to use Java programming language. This is in the LeetCode editor. If root equal null, I want to return root here. Otherwise, we can swap the root, which is root.left, then root.left equal root.right equal temp. So this is the swap part. Then later we can do invert tree root dot left, invert tree root dot right, finally return root. So this is the algorithm we followed for this recursive method. Okay, now if we run the code, accepted, let's submit, accepted, right? Now use the C#. So in this C# is the method, and everything looks good. Accepted, submit, accepted. Okay, now let's go to the Java again. Now I would like to use the iterative method, right? So in the iterative method, first of all we have to check if it is null, return root, otherwise we can create a queue. Then we can add the root into queue. Then while queue is not empty, we can swap the, first of all we have to pull the item from the queue, then swap the swap the children of that node, right? So we can create a temp variable and keep the one of the item like left, then current dot left equal current dot right, then current dot right equal the temp. This is the swap. Then later, if the current dot left is not equal null, then add to the queue. Similarly, if current dot right is not null, then add to the queue, right? Finally, not from here, oops, return root. So now we can run the code and see if there is any compilation issue. No. Submit. Accepted. Now copy this code and go into C#. So this time Q is Q here, and Q is like NQ, NQU, oops, right? Then instead of pull it should be DQ, and rest of the thing should be similar. Oops, compilation error. What is the issue here? Oh, in C# we do not have is empty, method in the queue. Instead they have count, so count will give like number of items in the queue. One more, there is no add, there is always enqueue and dequeue. Sorry for that, I forgot to change those method name. Accepted. So this was my first tutorial on LeetCode problem. I hope you enjoyed this tutorial. If you have any questions or opinions, please write it down in the comment section. I will try to answer your questions, and I will put this source code in GitHub, and I'll put the link in the description of this video. Also, please subscribe my channel and click on the bell icon to get the latest video notifications. Thank you.